Hi, this is Michael Eisner. I'm the head of California Special Projects, and I'm here to show you some new research in rigging. Before I go any further, I just wanted to comment on the project Aaron's talking about. So I've been teaming up with him, trying to help solve some of the rigging problems in this production. And as a starting point, I think the idea of this project was to push the envelope both artistically and technically. So the area I was focusing on first was character setup and doing specifically a quadruped. So the first problem we were looking at was a foot roll. If you look at, for instance, if you just get the default rigs in XSI, if you look at how that's working, if you go look at the roll on the foot, you can see there's a single breaking point, and that one breaking point foot is good for a human or some human scenarios, but for this quadruped, so here's the kind of rig underneath that. For some quadruped characters, you need more than that. So the first thing I started working on off the bat is a multi-roll that has multiple levels of offset, so that you can go in and you can show the breaking point. So let's say I want a more this one has a much deeper breaking point on it. For example, you can go right over here, or a very low breaking point, and also a level of offset for each foot. So at this level, you can say I want to correct the foot there, but that offset is carried throughout the roll. So this is the first thing we worked on. The second problem we started to look on is the distribution when you have a chain. So say you've got a chain for a dog leg. So it's coming down. So let me switch over here. So it's coming down something like this. When you've got such a chain, it's tricky to control the distribution between this bone and this bone. So you can actually, in XSI, if you draw a 3-bone chain, here, let's just draw one in the side view right here. So if I go look at these chains, if I go and draw my own, it's fairly tricky to really control nicely whether you want to distribute this way or you want to distribute that way, and you actually can get scenarios where you kick out too far. So you can go in here and start to mess with the stiffness. So use stiffness instead of stiffness value, say of, actually I want to forget this one. Use stiffness, I'll set a stiffness of 5. That will change the result here. So you can see this piece basically doesn't pull out because it's so stiff. I can lower that down, but it doesn't really give you good control. It doesn't lend itself to a system that really nicely controls that. So what I did is I went and made this new leg making tool, dog leg making. So you can go in and with a multi-roll and with the system to control that, you can run in and create a dog leg. Just pick part of this, and then it'll go in, and I'll hide the guide, hide both the guides, or delete them. So then you can go in here. This will move the leg, but this piece here will control the distribution between them. So if I rotate it in this angle, you can see it's switching between it. So you can have the foot step, get up quite tight, and then you can control the lift as it steps forward on that point. I gotta watch my up vector there. So it can control back and forward, and then within that there's also a roll that's all intertwined together. So it's actually a pretty tricky engineering problem. All these points can break independently with that multi-foot roll I showed you. So you can have the foot come, step down, and then the quadruped can add force and accelerate forward as it steps into the ground. So this is one area I spent a lot of time working with Aaron and doing animation tests and creating a system that can do that. So when you go and look at it inside the characters, so we rig this guy here, then what it results in is you can move around. Here, I'll just shift down to a lighter level of subdivision. You can move around the character very easily and control the distribution. say here, between the different legs. So you can have this step forward, have it roll, and control the force being applied. And what's nice too is it won't step out after another a certain position, a certain percentage. You can control basically the locking of the leg, so the leg here will not push forward beyond a certain angle, and that angle varies depending on what kind of animal you're dealing with.